Hello everyone, so we are picking up where we left off with balancing chemical equations, and in this video we are just going to keep working through more practice examples. So this example, if you recognize, it is similar to the first example of the last video in that it's a combustion reaction. And the way we know that it's a combustion reaction is because we look at the products CO2 and H2O. And remember, CO2 and H2O are indicative of a combustion reaction. In addition, you have O2, oxygen gas, as a reactant. So those three compounds tip you off that this is a combustion reaction. And then what changes is that first compound, that hydrocarbon of carbons and hydrogens. So remember that the tip for a combustion reaction was to balance it in the order of carbon, hydrogen, and last oxygen. And again, that's because the O2 on the reactant side, that is our least complicated of the four, and so we want to leave that for last, which means that we'll leave the oxygen for last. So we draw a line down below the arrow, and we separate the reactants from the products, and I'm going to list them as carbon, hydrogen, and oxygen in the order that I want to balance, and repeat that on both sides. And because we have not put any coefficients yet in front, then we can determine the number of atoms for each element by looking at the subscripts. So for carbon on the reactant side, we have a 3. For hydrogen, it's an 8. And for oxygen, it's a 2. And then on the product side, for carbon, we don't see anything, so we're going to put a 1. For hydrogen, it's a 2. And then for oxygen, if you notice, it's in 2 compounds. So because of that, we're going to split it up and put the 2 from the subscript 2 of CO2, plus we're going to leave some space, and then a 1 from the H2O because you don't see a subscript. Okay, and we're going to leave quite a bit of space between those two. You do add them together when they're coming from 2 separate compounds. So we have 2 from CO2 plus the 1 from H2O. Right now we have a total of 3 oxygens. Okay, now looking first at the carbon, we notice that we need to have 3 carbons on both sides of the reaction. So I need to increase the number of carbons on the product side. And if I want to have 3 carbons, I need to decide 1 times what gives me 3. Well, that's a 3, so we're going to put a coefficient of 3 in front of CO2. And as soon as I put that 3 in front of CO2, it not only affects the carbon, but it also affects that oxygen. And notice how it's only the O2 oxygen. It's not affecting the H2O oxygen at all. So that's why I separated out the 2 and the 1 for oxygen, so that I only multiply that 3 times the 2. Okay, now the next thing that we want to balance are the hydrogens. And hydrogen, we have 8 on the reactant side, so we need to come up with 8 on the product side. And I need to decide 2 times what gives me 8. Well, 2 times 4. So if I say 4, that's the coefficient that I need to put in front of H2O. And that 4 distributes not only to the hydrogen, but also to the oxygen. So we need to multiply that 4 times the 1 oxygen that we have. Okay? Now the carbons are balanced, the hydrogens are balanced, and the only thing left are the oxygens. And so we want to add up all the oxygens that we formed on the product side. And we have 3 CO2s, so we have 3 times 2 gives us 6 oxygens from the CO2, plus we have 4 times 1, 4 oxygens coming from that H2O. So total, there's 10. And on the reactant side, if I want to have 10 oxygens, then I need to decide 2 times what gives me 10. And the answer is 5. So 5 is the coefficient that I put in front of O2. And so now this is balanced, and we have CH C3 H8 plus 5 O2 yields 3 CO2 plus 4 H2O. Okay, in the second example, we're going to start looking at those polyatomic ions. So if you remember, I said that the best way to spot a polyatomic ion is to look for something in parentheses. And so it may help to first ignore the physical states, because remember, those do not matter for balancing chemical equations. And then the only thing that you see in parentheses is this NO3. Okay, so everything in parentheses, that is our polyatomic. And so when I list my elements on either side, we've got Na, F, TH, and then for that polyatomic, I want to keep it as everything that I see in parentheses, which is NO3. And you may find it helpful if you put parentheses around it, and if you look for it on the product side and go ahead and put parentheses around it on the product side as well. And then we want to list all the elements in the same order on the product side. And again, we are starting out with no coefficients, so we determine the number of each element by looking at the subscripts. Okay, so sodium and fluorine, Na and F, we have 1 apiece because there's no subscripts for those two. And TH, same way, there's not a subscript there. And now that NO3, we want to look outside the parentheses to see what the subscript is on the outside of the parentheses. And so on the reactant side, that's a 4. And then on the product side, again, we have 1 sodium and 4 fluorines, 4F, 1 TH. And then if you notice NO3, there's nothing outside of that parentheses. It's a simple NO3. So that would be 1. Okay, now we want to look for the monster. So of these 4, which looks the most complicated? And you're going to want to pick something that contains the polyatomic ion. So we're looking at either the reactant or the product that contains NO3. And we want the one that has the most. So the reactant side has 4 NO3s. So that's where we're going to start. This is what we call our monster. Okay, now we're going to look at the elements inside that monster and see what is unbalanced. And the THs on both sides of the reaction, if you notice, we have 1 of each. So we look next at the NO3, and we have 4 NO3s on the reactant side and only 1 on the product side. So if we need 4 NO3s on the product side, then we have to multiply 1 times 4, and that 4 becomes our coefficient. So when we place the 4 up as our coefficient, it not only affects that nitrate, but it also affects the sodium. So we'll multiply the sodium by 4 as well. Okay, now we bounce back to the reactant side. Since I affected the sodium on the product side, I want to look at it on the reactant side. And I only have 1 sodium, so I need to increase the sodium on the reactant side to equal 4. And therefore, I have to multiply the 1 times 4. And what I multiply by, that becomes my coefficient. Okay, so I have 4 sodiums, and it not only affects the sodium, but the fluorine, or the F, as well. So I'm going to multiply F by 4. Okay, well, once I do that, I've affected the fluorine, so I want to go back and look at the fluorine on the product side, and those match. I've got 4 of each, and now everything is balanced. So my final reaction would be 4 NaF plus THNO3 yields 4 sodium nitrate, NaNO3. And I do want to leave the parentheses that I added back out of it. 4 NaNO3 plus THF4.